Tomcat is one of the most widely used Java application server. In this video, I'm going to show you the overall structure of Tomcat and two of the important components of the Tomcat, the connector and the container structure. And we will also go through the source code using a demo application. This is the Tomcat structure. Basically, it is a server. So the corresponding class is a standard server. It implements the server interface and further implement the lifecycle interface. One standard server might have several standard services, which also implement the service interface. The standard service is the center component from the source code view. It has two parts, the connector and the container. The connector is dealing with the network request and the connection, and the container is dealing with the content of the incoming request. So first we will look into a bit detail of the connector. So one service might have several connectors, and each connector has a protocol handler and an adapter, because the connector is dealing with the network connection, so it might have different protocols. In the protocol handler part, the acceptor, puller, and executor are the first components that dealing with the incoming network requests. So we will look into a bit detail of these three components. Here we can see the acceptor, puller, and executor. We can see that acceptor and puller both implement the runnable interface. So actually they are running in two separate threads. An acceptor has its own thread, or puller has another running thread. The acceptor will adding the pull event into a synchronous queue, or the puller will remove those puller events from this synchronous queue. The acceptor accepts the new connection, and then it's wrapped in a puller event and then adding to the synchronous queue. And the puller has the puller thread has two main tasks. One is pulling the event, another is check the selector. When the puller thread is pulling the event, it will trigger the run method of puller event. We can see the puller event also implements a runnable interface. In the puller event run method, it will register the wrapped socket channel into the selector. So this is a very typical Java NIO non-blocking multiplexing model. The puller thread then will check the selector, call its selected key method, and get the selection key, and then wrap it with the socket processor and submit to the thread pool. So we go back to the connector part. So we can see these three components wrapped the incoming request into the socket processor, and then once the thread pool call that socket processor, it will choose a connection handler. And the connection handler will decide which protocol this connection is used, and then we'll call its corresponding protocol handler. Like in our example, the protocol is HTTP 1.1, so it will call HTTP 1.1 processor. And in HTTP 1.1 processor, it will call the Toyota adapter. In Toyota adapter, it forms the request and the response, which will be used in the container part. Now we look into a bit detail of the container part. As we can see, one service has one engine as the container, and one engine might have several hosts. And one host might have several contexts. And one context might have several wrappers. So each level of the container has similar structure. They both have a pipeline. For example, the engine container has a pipeline which has one node, standard engine valve. So the incoming request from the Toyota adapter first reach the engine's first node of the pipeline, and then once the pipeline node process it, it will send the request to the host, the pipeline's first node, and then the first node will send to the next node until reach its last node. Then it will send into the context pipeline, and the context pipeline send the request to its next node, and then standard context valve is the last node of context, and then it will send the request to the wrappers pipeline, which only has one node called the standard wrapper valve, and it will call the filter chain. This is the application filter chain. Once the request goes through the filter chain, it will finally reach the servlet. So now I'm going to go through the source code with a demo application. So this is the structure of the demo application. So in the browser side, we just input the name and click the login button, and then the server side has a demo servlet. It implements the doGet method and send the response back. So here we can go through this application. So if we input the name like Billy, and then if we click login, and we get welcome Billy back. So here is the source code of Tomcat. So I already started the Tomcat instance in debugger mode, and there is a client application. I use HTTP client. It has one HTTP GET method request. So it's just use hard-coded URL. So I will trigger this. Client application, and then it's already triggered here. So I just let go. So once the client send the request, we can see in the server side, the acceptor thread get the request. This is the acceptor thread run method. We can see the server socket accept method accept that connection and then return the socket channel, and then we wrap the socket channel through the set socket option method. So here is the UML sequence diagram. So in the NL endpoint, the acceptor thread run method, it will call the server socket accept method and then call the set socket option. And then in this set socket option, it will first set the socket non-blocking and then wrap the socket with the NIO channel and then call the puller to register channel. So this is the register method. So we just go through this method. In this register method, the socket is wrapped in pull event. And then we just add that pull event. So this is where the pull event is added to the events, which is a synchronous queue. So this is what we see here. The acceptor thread add the pull event, and in the sequence diagram, it is just register the socket channel into the synchronous queue. So let's go on. So now we are in the puller thread run method. So in the puller thread, it will go through all the pull events. So we are in the events method. It has a for loop, which will go through the synchronized queue and pull the pull event out, and then call the pull event run method. So now we are in the pull event run method. It will get the I/O channel from the socket and register this I/O channel to the selector. So this is where the puller thread run method call the pull event run method. Then it will register the socket channel into selector. So we just let go. Here we are still in the puller thread. As I mentioned before, the puller thread do two things. First is enqueue the pull event. The second is it will call the selector's select method. So once there are incoming requests, so the key count will bigger than 0. So if the key count is bigger than 0, the selector should have more than one selected keys, and then we just iterate through all those selection keys, and then process it. Because we are in debugger mode, so we go through the timeout path, which is also finally will process the socket, the same as process key. So basically it will get the selection key and process it. So we are now in the process socket method here. So here is still in the in the puller run method. It will call out the process socket method in and out endpoint. So in this method, it will wrap the socket wrapper into the socket processor. The socket processor has a subclass called the socket processor base, which also implements the runnable method. So once the socket wrapper is wrapped into the socket processor, then we can submit it to the thread pool. So here we get the executor, which is thread pool, and then we submit the socket processor into the thread pool. So this is here. It will submit the socket processor into the thread pool, and then we just going. So here we are in the wrapped runnable run method of the worker thread. So the worker thread will call the wrapped runnable, and then the wrapped runnable will call the wrapped objects run method, which is the socket processor base method. Then it will call the do run method. It will call the do run method. Then it will get the selection key from the wrapped socket, and then process some handshake. Finally, it will call the handler to call the get handler to get the connection handler. Here, the work thread run method will call the socket processor's run method, and the socket processor run method will get the connection handler and call its process method. So this is where it get handler, and once it got the connection handler, it will call its process method. Here is the connection handler's process method. It's in connection handler's process method. So it will first get the processor from the cache if the process is not in the cache, it will get the protocol. So it will make a decision which protocol this socket processor is, and then create a protocol processor for it. So here we can see it is HTTP 1.1 processor. So basically we can see, go back to our connector structure. It is the socket processor will call the connection handler, and the connection handler decide which protocol and call the corresponding protocol processor. So the connection handler will call the HTTP1 processor here. So just like then in its super class, it will call the processor's service method. We first call the processor's process method. Actually, this process method is in its superclass. The superclass then will call back the base class's service method. So we just let go. So now we are in the HTTP 1.1 process method, the service method. In this service method, it will deal with some basic HTTP signaling. Like for example, if the endpoint is paused, then it will send the status 503 back. If the request is bad, it will send 400 back. So it will, because it's HTTP 1.1 processor, it will deal with some basic HTTP messaging. But the content, like 500 internal server error here. But the content of the load of HTTP load is get from the adapter. So we will call here we get the Coyote adapter and call it service method. We will call the Coyote adapter and get service method. So here. So the processor, HTTP1 processor, deal with some basic HTTP messaging, and for the content part, it will call the Coyote adapter service method. So now we are in the Coyote adapter service method, so we just go. It will first create the request and response. If you have experience in developing the servlet application, so you know these request and response are the key components. And then we just like in the adapter, we just keep going. So finally we reach here. So this is the line where the Coyote adapter send the message from the connector to the container. So as we go back to this diagram, this Coyote adapter is acting like a bridge between the connector and the container. So we go back here. So here is the connector, and here is the container part. So the create adapter is just a connector, forward the request from the connector to the container. So this is the line. So the adapter has the connector, and then it called get service, which is getting this service, and the service know where the container is. So we can see here. So when we get a container, we got a standard engine here. And then standard engine has a pipeline. Then we get the standard engine's pipeline. And then get the first node of pipeline. So this is basically like we show. The create adapter request coming, and then it will call the engine's pipelines first, which is also the last node called standard engine valve. So we just go on. We just let go. So now we are in the standard engine valve. So the create adapter called invoke method of standard engine valve. In the standard engine valve, it gets the host and not do much, and then it will call the host pipeline the first node. The host pipeline the first node, as mentioned here. The standard engine valve will call the host pipeline the first node. So we just let go. And we can see the first node of host pipeline is abstract access log level. So we are in the abstract access log level. So again, we just go. So then this node will just call the next node. So we are here. So the log valve will call the next pipeline node. We're getting that pipeline, we just go on. Then it will call error report valve invoke method. This is the second node of the pipeline. And then the first thing it does is just get the next node of the pipeline and invoke it. So we just let go. Then we reach the standard host valve. We reach the standard host valve, which is the last node of the host pipeline. So in this node, we get the context. Then we will again do the similar thing. It will call the context pipeline's first node. So we can here. So we called the last node of the host valve, and then it will call the context pipeline's first node, which is no login authenticator. So here is the code. The context get the context pipeline's first node and invoke it. So here it is. So we are kind of here. So we are in the context first node, which is called authenticator base, which is a subclass, and also non-login authenticator. So we are in the authenticator base, and itself is non-login authenticator. And then in this method invocation, it will do some authentication. And after this, it will call its next pipeline. Which is a standard context valve. So in the sequence diagram, it will call the standard context valve from the authenticator called the standard context valve. So we just let go. Here we reach the last pipeline valve of context, which is standard context valve. You can see here, which is the standard context valve, which is the last valve of context pipeline. And what it did is it just get the wrapper out, and then call the wrappers pipeline's first node. Then it called the wrappers pipeline first node, which is also last node, which is called the standard wrapper valve. In the sequence, the standard context valve will invoke the standard wrapper valve. And we just let go. So in the standard wrapper valve invoke method, so we can see here it did get the content. It will get the servlet. So this servlet will be allocated from the wrapper. So here the servlet is now. Then once we just go, so we get the servlet, which is the demo serve, which is our demo servlet. So it will go. So in this valve, it will also form the application filter chain and call the application filter chain. So here it will, the standard wrapper valve will call the application filter chain, just like here. So this valve will call inside the application filter chain and do the filter, and then we go. Then in the filter chain, it will check how many application filter it is. But in our demo application, I did not set any application filter, so the n is 0. So it will just ignore those application filter chain. So it will directly call the servlet service method. So here we can see it will call the servlet service method. So we just let go. Here is the demo servlet, which extended HTTP servlet. So it only one method, which is do get. So it is set the content type and then just write get the parameter. Here we get the parameter and then write the parameter back. Yeah, see, we get the parameter which is Billy, and then send this welcome Billy back. So we reach the last step, which is the service method of demo servlet, and then we just let go. Here we all the methods are returned, so we reach the Coyote adapter. I set a breakpoint here because we still need to call the response, finish response method, because the response is still cached somewhere. So in the client, we can see we send out the request, but we still not get the response. So we let go this method, and then the cache is flushed out, and then we can see the we can see this welcome Billy message back. So if we go through the client application, we can see welcome Billy message is print here in the console. So basically that's it. So we go through the request from the network part and all the way to the container part, and then go through all the pipelines of each container, and finally we reach the servlet. So if you want to look into the source code, I think you can download the Tomcat source code and just look into those diagrams, and especially the class name, which is the key components, and then you might still need spend some time by yourself, and then you will finally understand the whole procedure. I hope this video could help a little bit. Thank you.